What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Security Plus 601 certification exam. So let's get into it. In this video, you're going to learn about embedded systems constraints such as power, compute, network, cryptography and authentication, inability to patch, range, cost, and implied trust. All right, let's talk about power. So embedded systems are built for specific purposes and are optimized to meet different kinds of constraints such as performance, timing, power, and cost. Power consumption is one of the main design constraints for embedded systems, to which a designer must balance power consumption with features and capabilities. Attackers can exploit systems by causing a system to shut down or crash by simply causing loop instructions somewhere on the system to consume all power. So when these devices are deployed, securing power sources and ensuring adequate power during the device's highest utilization periods should be a consideration. Next, let's talk about compute. So embedded systems typically have tight constraints on both functionality and implementation. In particular, they must guarantee real-time operations reactive to external events, conform to size and weight limits, budget power and cooling consumption, satisfy safety and reliability requirements, and meet tight cost targets. Many embedded systems are physically located within larger artifacts. Therefore, their form factor may be dictated by the aesthetics or form factors existing in pre-electronic versions. In transportation and portable systems, weight may be critical for fuel economy or human endurance. So for example, a mission-critical system like a black box would have more stringent size and weight requirements than others because of its use in flight vehicles. Next is network. So an embedded system is often used to interact with the environment for the purpose of monitoring and controlling external devices. To do this, analog inputs and outputs must be transformed to and from digital signals. In some systems, smart sensors and actuators that contain their own analog interfaces, power switches, and small CPUs are often used to offload interface hardware from the central embedded computer. This brings an additional advantage of reducing the amount of system wiring and number of connector contacts by employing an embedded network rather than a bundle of analog wires. Next, we have cryptography and authentication. So cryptography, this is the art and science of manipulating data so that outside parties cannot undo or mimic the manipulation without knowledge of a secret. It enables high-level functions such as confidentiality of information during storage and transmission, authentication of users, integrity of retrieved information, non-repudiation of transactions, availability of data and resources, controlled access to information and resources. While there are many benefits in terms of security offered by cryptography, there is a downside. Cryptography is very computationally intensive, and the extra processing steps involved in security protocols can create a heavy CPU utilization tax on systems that use cryptographic security frequently. Next constraint is the inability to patch. So a patch, this is a set of changes to a computer program or its supporting data designed to update, fix, or improve it. However, not all patches resolve issues they were designed to address. As a matter of fact, upwards of 25% of all patches fail to fix the issue and directly cause problems for an end user. And to make matters worse, 40% of these faulty patches result in crashes, hangs, data corruption, or additional security issues. When it comes to an embedded system, a bad actor could just simply break or remove some functionality that was previously relied on by the control system patch in order to cause problems with the system. Next constraint is range. So embedded systems are typically constrained in terms of 3 system performance criteria, and they are space, time, and energy. Performance requirements are directly translated into constraints imposed on the system's resources, such as code size, execution time, and energy consumption. These resource constraints conflict with each other in a complex manner, making it difficult for a system developer to apply a well-defined design methodology in developing a real-time embedded system. The smaller the device, the more direct relationship to the size of the transmitter, thereby dictating the frequency and distance range the device supports. So the smaller the transmitter, then the shorter the range distance will be. The next constraint is cost. So even though embedded systems have stringent requirements, cost is almost always an issue. Although designers of systems large and small may talk about the importance of cost with equal urgency, their sensitivity to cost changes can vary dramatically. A reason for this may be the effect of system costs on profitability is more of a function of the proportion of cost changes compared to the total system cost rather than compared to the digital electronics cost alone. And then we have implied trust. So implied trust, this is where a specific section of code or component depends on the previous code or component for its security, thereby making it reliant on that code to have appropriately performed the security measures required to make the entire system safe. When it comes to cybersecurity, implied trust should be used sparingly as it relates to embedded systems. There are constraints that limit what full-fledged trust can be implemented, but alone what can be operationally expedient. Therefore, certain aspects of the design rely on an implied trust, even if that is assuming a wireless network will be secure so that there is no need to protect plain text protocols. All right, so that was my quick little video on embedded system constraints, where we talked about constraints such as power, compute, network, cryptography and authentication, the inability to patch, range, cost, and implied trust. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Security Plus 601 certification exam. And until next video, ladies and gentlemen, peace.